The velocity of a wave in a medium is constant. It doesn't matter how much extra energy you put into a wave, it will still go the same velocity in the medium. That's what constant means. Think about this with sound. You can put more energy into your voice by yelling, but yelling doesn't make your voice arrive sooner. It might make it go farther, but it takes the same amount of time to get there. Velocity in a medium is constant, and wavelength cannot be controlled, so the only thing that can be adjusted is the frequency. Frequency is the amount of cycles per second and can be sped up or slowed down at the source of the wave. Since velocity is constant, when the frequency gets smaller numerically or has less cycles per second, the wavelength gets larger. Likewise, when the frequency is increased at the source to have more cycles per second, the velocity, which is the product of the frequency times the wavelength, is still constant. The only thing that can change is the wavelength, which decreases, becoming shorter. In a different medium, the velocity could be larger. For instance, in air, sound travels around 343 meters per second, depending on the temperature, and thus the air density. But in diamond, sound travels around 12,000 meters per second. It doesn't matter that the velocity is much larger in the diamond. The same relationship remains. When the frequency goes down, gets smaller, happens less times per second, the wavelength is longer. It gets bigger, higher. The product between them, velocity, is still constant, unchanging. When the frequency goes up, or gets larger, or happens more often, the wavelength becomes shorter, smaller, has a lower value. But the wavelength times the frequency, which is the velocity, is constant. Interestingly, though, when a wave crosses from one medium to another, like from air to diamond, for instance, it is the frequency that remains constant, with the wavelength and the velocity being the aspects of the wave that change.